Please welcome Bruno Benevolo.
Good morning, good afternoon, good evening. Pleasure to be here. My name is Bruno Benevolo. I'm Director of Enterprise Solutions at SSI. And today we're going to be talking about data complexity in shipbuilding and some of the challenges that we've seen in that industry and how PLM can be an important information platform to address some of those challenges. So I'm going to share my screen here. So please bear with me. Okay. So today, going to have a quick overview of SSI. Then we're going to be looking at some of the challenges in terms of data complexity in shipbuilding, and also we're going to be looking at some specific use cases, some shipbuilding PLM solution stories as well. So SSI is a company that's focused on empowering the business of shipbuilding via digital transformation. We have over 440 clients. One ship is delivered every day using SSI technology, and we've been in business for over 30 years. So we have developed a lot of expertise around shipbuilding and offshore, and we have developed also very much partnerships with a lot of our clients and being involved in their digital transformation journeys. So we have clients across both defense, commercial, offshore shipyards, and also from significant shipyards and design offices in terms of scale, and smaller shipyards and design offices as well. And I think that's one of the key aspects of SSI technology is that our solutions, they need to scale, but they also need to be simple and adaptable to address both small design firms and also large shipyards as well in terms of processes. So that's something that's been very much in the DNA of all our technology, having that flexibility and adaptability as well. Specifically around the defense sector, naval defense projects is really an area where SSI has excelled. And for PLM, from a PLM perspective, that's particularly relevant because defense projects often have significantly quite long build cycles. So you do have a lot of change that's taking place during that, during the whole shipbuilding design and then construction and handover process. So we definitely see that PLM is particularly relevant for the defense sector. So as I mentioned at the start of my presentation, shipbuilding is a unique industry in terms of some of the challenges and complexities. And here we have a nice image where we see a 747 and a ship next to each other. And so although aerospace, you do have some similarities, there is one key difference here that I'd like to point out for those that are not familiar with shipbuilding. So when you think about a commercial airline, or you've essentially developed that design, you've created a full prototype of the model for testing before you actually start rolling out actual product to your client. In shipbuilding, your first hull is your prototype, and it's also effectively the vessel that you're going to hand over to the client. And then one of the key challenges you face in the industry is that often you will start actually manufacturing processes. You'll start cutting steel, for example, with only 50% of your design process completed. So you do not have a complete BOM. You do not have that luxury of a complete awareness of your design and the bill of materials. So you will have a lot of simultaneous processes happening on. You still have procurement, planning processes going on, manufacturing processes going on as you're still designing. So on top of all of that, you also have change. So you can imagine how much complexity you have in terms of all of those simultaneous processes going on and change management also kicking in, and you're having to try to understand what is the impact of change across all of those processes. Another aspect when you talk about large vessels and defense vessels, we're really talking about a different scale here in terms of complexity of the actual model. So you need to fabricate millions of parts, you have tens of thousands of assemblies, and over a large shipbuilding project, you'll need to manage thousands of changes. And again, in the defense sector, that's particularly relevant. And sometimes those changes also need to manage across sister ships as well. So when we think about the whole shipbuilding lifecycle after handover, you also have the challenge of maintaining that digital data post-delivery as well. So we do see the industry right now going through a transformation where there is increasing awareness of the opportunities of leveraging, what we've been hearing a lot in this conference, this idea of the digital twin, an enriched digital twin that can be relevant for post-delivery use cases. But still, what we see is there's still a lot of legacy data, still a lot of 2D drawings. So you need to have an environment where you can embrace all of that data set, both legacy data and also 3D models, to successfully address maintenance and retrofit demands post-delivery as well. But if we look right now at the shipbuilding industry, we feel that there has been, there has been success in terms of adopting digital transformation. Certainly on the design side, of tools have been adopted to develop 3D models to allow that 3D data and 2D output to be fully digital and shared within the organization. You also have a lot of shipyards have adopted ERP or even MES systems as well. But one of the challenges, a lot of that information, that product data, is still being managed in file shares. So when we talk about the product data, we talk about the requirements, the VFI, your test plans, your sea trials information. A lot of that will be in Excel sheets and PDF documents and drawings, and that's just floating around with typically, you do not have a very clear idea as to what processes can manage all that information coherently as one configuration control data set. So with all those isolated data silos, you do have data fragmentation, poor information retrieval, and it really becomes very tough for you to manage change across that sort of system architecture. So this is what we call the digital transformation roadblock. So the integrated information platform is SSI's vision as to how we might address some of those challenges. So as we've seen, we have all of these artifacts, requirements, VFI, drawings, 3D models, parts, bombs, and we need to have a platform where you can not only store that information, but also see the relationships between those artifacts and also configuration control that information and have revision history as well to see how that information has changed over time. As we can see, you also have the need here to manage change across the full shipbuilding design life cycle and also during construction, also afterwards post-delivery. So SSI has partnered with ARIS to develop ShipbuildingPLM, which is a vertical solution on top of the ARIS Innovator technology foundation. And we leverage ARIS Innovator's outstanding data model relationship capabilities in terms of being able to support multiple objects, a diverse product data set, understand those relationships, and also offer a low-code environment for us to implement a shipbuilding specific data model and also configurations in terms of processes and visualization that can address shipbuilding specific needs. So this is what we call ShipbuildingPLM. It is our vertical solution on top of the ARIS platform. When we look at the shipyard, as we can see here, we have a tight integration here in engineering with ShipConstructor, which is SSI's own 3D CAD/CAM design tool. And we can leverage that data set within ShipbuildingPLM, within the ARIS Innovator platform. And also, obviously, there'll be other information as well that will be coming to that platform that needs to be shared throughout the organization. But SSI very much understands that we live in a world where platforms need to talk to other platforms as well. It's what we call our platform of platforms approach. So it's not only important for us to have great technology in terms of our shipbuilding PLM vertical on top of the ARIS platform, we also need to have partners that are specialists in specific areas that we do not have expertise and be able to integrate our solution with their solutions as well. So as we can see, SSI partners with other design tools in terms of initial design, electrical design. We also partner with planning, shipbuilding specific planning tools that offer capabilities, even in terms of artificial intelligence, in terms of organizing that planning capability. And we also partner with manufacturing execution systems, and also CAM, shop floor automation technology, such as profile cutting machines, panel lines, and even robotic welding as well. So this is very important from an SI perspective. Being able to partner with ARIS allowed us to carry on with this platform of platforms approach, which was also the ARIS approach. So let's now look at some shipbuilding PLM solution stories and see how shipbuilding PLM can help you get your shipbuilding data unstuck and also help you proceed in your digital transformation journey. So as I mentioned, one of the challenges you face currently with some of the current shipyard system architectures that don't have this sort of information platform is just finding information. It's product data retrieval. So here we can see shipbuilding PLM, and we've developed our own configuration objects that understand shipbuilding data. Here we can see we have an integration of our digital mock-up environment in Navisworks. And we also are leveraging some of the new ARIS capabilities in terms of 3D visualization within this browser environment as well. So that allows, you move away from a scenario where previously engineering data was locked away, the 3D model locked away in engineering, and you had to be very much a specialist to be able to access that, to now have an environment where people can have early access, configuration controlled access to 3D information to do their work. So we obviously are managing the 3D model information all the way down to the part level. So here, for example, when I click on that model, I can actually go directly to a specific equipment part. I can see what changes are involved, and we can see here we've got a specific tag information, what compartments it's associated to. So all of this information has come in from the 3D design tool and now can be leveraged within the organization. You can also search. Once you have that information within this sort of environment, you can, for example, do these sort of searches here. I want to see other drill cutting feeders that are being used. So I could search across hulls, across class programs to see where I have applicability for a given equipment item. And here we're seeing we are actually tracking, it's what we call the true digital twin. We are tracking each individual part instance of this equipment with its individual tag number as well. And then you can have unique identifiers or even serial number identifiers for post-delivery ILS tracking requirements. You also need to have a system view of your information. So as well as your system view, which is important in terms of 3D visualization, you also need to be able to link that information to your functional schematic drawings as well. And here we can see you have the ARIS platform offers this rich collaboration environment where you can also add comments, markups, which helps you through the design review process as you proceed with approval of the design and any changes that you're implementing as well. So when we look at some of the integration we've done with our digital mockup as well, our environment called Ship Explorer on top of the Navisworks platform, we can see that from within this digital mockup environment, you're pretty much one click away from accessing VFI information, functional drawing information, part catalog information for this specific pump. And we can also bring in federated data, for example, from ERP and MES systems. So you can see that this specific pump is in a testing phase, it's part of a systems testing phase for a given shop order as well. So change management is also an important part of our solution as well. So we need to be able to track change, and we've developed specific change objects as well that allow us to visualize change. And here we can see changes that have happened and be able to communicate that information visually as well. Production data control was also important. So here we can see the assembly information. Planners can use this information to investigate within the shipbuilding environment there how things are effectively put together within the shipbuilding environment, and we track that all the way down to the part level, to the nest level as well. Here, for example, we can see also spool drawing. So the spool information, or also any pipe geometry information that needs to be fed to pipe bending machines, for example, can also be fed and configuration control through shipbuilding PLM. Okay, please do visit our stands later, where I can give you a full demo of this platform technology and see shipbuilding PLM in action. But I'd just like to end my presentation here with a wrap-up of some of the unique advantages that we feel we bring with shipbuilding PLM. So shipbuilding PLM has been developed with DNA that's focused on the shipbuilding industry. We offer an integrated view of product data throughout the shipbuilding lifecycle. We support concurrent change across shipyard disciplines, and because it's been developed on top of the ARIS technology platform, we have a vertical PLM solution that's adaptable and resilient. And what we're doing in shipbuilding PLM is we're allowing shipyards and shipbuilding design offices to start their PLM journey already on the first base, where they already have that environment that understands shipbuilding PLM data. So that we will allow you effectively to proceed on your digital transformation journey and help you get your shipbuilding data unstuck. So again, please do visit our booth. You can find us there in the lobby area, and I'll be more than willing to have, as I say, a virtual coffee and have a conversation and carry on any discussions or any questions that might arise based on this presentation. So thank you very much.